Problem number 17. A spherical cloud of dust in space has a uniform density ρ0 and a radius r0. The gravitational acceleration of free fall at the surface of the cloud due to the mass of the cloud is g0. A project occurs heat expansion that causes the cloud to suddenly grow to a radius 2r0 while maintaining a uniform but not constant density. The gravitational acceleration of free fall at a point r0 away from the center of the cloud due to the mass of the cloud is now next one. Solution. Here we can use just Newton's gravity law. According to this, free fall acceleration on the surface of a sphere with a mass m and radius r equal to this expression. In our case, mass inside of new sphere was reduced 8 times, and the shell which is above this surface not affecting this g. So it means that g was decreased 8 times, which is correct answer C. Problem number 18. Consider the following diagram of a box and the two weight scales. Scale A supports the box via a massless rope. A pulley is attached to the top of the box. A second massless rope passes over the pulley. One end is attached to the box and the other end to scale B. The two scales indicate the tension TA and the TB in the ropes. Originally, scale A reads 30 newtons and the scale B reads 20 newtons. If an additional force pulls down on scale B so that the reading increases to 30 newtons, what will be the new reading on the scale A? Solution. Here the only matter is difference between TA and TB, because it's showing what is the weight of all this construction, and it must be constant. So it means that if we increase scale B by 10 newtons, we must increase the same for TA. It must be equal to 30 plus 10 newtons, which is 40 newtons, and this is correct answer B. Problem number 19. A helicopter is flying horizontally at a constant speed. A perfectly flexible uniform cable is suspended beneath the helicopter. Air friction on the cable is not neglectable. Which of the following diagrams best shows the shape of the cable as the helicopter flies through the air to the right? Solution. Let's take a small piece of this cable, and on this piece there are two forces acting. One force is vertical force of gravity, and the other is horizontal force of air friction, and they both are proportional to length of this piece. It means that we have net force which is pointing down and left, and they are the same for any piece of this cable, proportional to length. It means that the line must be straight and pointing down and left, which is correct answer B. Problem number 20. A crew of scientists has built a new space station. The space station is shaped like a wheel of radius r, with essentially all its mass m at the rim. When the crew arrives, the station will be sent rotating at a rate that causes an object at the rim to have radial acceleration g, thereby simulating Earth's surface gravity. This is accomplished by two small rockets each with a thrust T newtons, mounted on the station's rim. How long a time T does one need to fire the rockets to achieve the desired condition? Solution. First, let's write equation for needed acceleration of gravity. So finally we need to provide omega due to this equation. So that will be omega equals square root from g over r. From other side we can write equation for rotational motion. So we use two rockets with a thrust T newtons. So it means that we have equation I alpha equal to TR, where I is moment of inertia for this rim, alpha is angular acceleration, and R is radius. In our case, I equal mr square. It means that alpha equal to 2t over mr. And finally, omega must be equal alpha t. And now we can put for omega this expression and for alpha this expression. And we have this formula to find what is t. Finally, t equal this expression, square root from gr multiplied by m over 2t, which is answer B.